My name is Randy Seppala, the project manager for the underground development at Resolution Copper. 10 shaft was developed as an exploration shaft to access the ore body and characterize the ground conditions and working conditions at depths. During the development of the mine, the shaft will be used as a service shaft to transport personnel and materials underground. During production, the shaft will be used as a ventilation shaft, providing intake air to the underground workings. In November of 2014, we completed number 10 shaft to a depth of 6,943 feet, making it the deepest single lift shaft in North America. During the sinking and construction of the shaft, as we developed it, we continually encountered significant water inflows. In order to complete the shaft, we had to construct a temporary pumping facility to keep the shaft dewatered. Upon completion of the shaft, we then developed a pump station to have a permanent dewatering facility to protect the shaft infrastructure. The TPL2 station was designed and installed basically for pumping water out of the bottom of the shaft to the water treatment plant. The station is located at a depth of 6,780 feet, which is about 160 feet off the shaft bottom. Basically, we take the water from the shaft bottom, pump it up to some holding tanks, and it's pumped from there. Current inflow is about 500 gallons per minute. We've installed two 700 gallon per minute high-speed turbine pumps for a total capacity of 1,400 gallons per minute. This provides double redundancy to perform maintenance or if we have any issues with the pumps. The water is pumped up vertically 2,200 feet through two 6-inch pump lines to a mine level that then takes it out to the water treatment plant at the west plant. Included in the construction is a significant amount of electrical work, including substation, transformers, switchgear, and PLCs. The operation of the system is managed through a PLC control system consisting of fiber optics communications so that we can monitor and control the system from the surface. The other technology we have is these are single lift pumps that are pumping up against a vertical head of 2,200 feet. They operate off of variable frequency drives so that we can vary the speed to the varying inflows. Along with all this is a vast array of instrumentation to monitor flow, pressure, temperature, and vibration. Another function for this pump station is we excavated a drill station, and that's what we are now commencing on, drilling some holes for geotechnical characterization and then also future dewatering for 9-shaft sinking. Development of this station, we use conventional drill and blast methods to excavate about 300 lineal feet of 16-foot by 16-foot drifts. Ground support consisted of resin rebar, rock bolts, cable bolts, and shotcrete. When all the excavation was done, we poured concrete on the floors, including drainage ditches, sumps, and pumps to handle localized water, which is still flowing into the station. Included in that is a large amount of piping, valves, large tanks, all of which had to be disassembled, lowered down the shaft, reassembled, and put together. In terms of schedule, work commenced in mid-January of 2015. Excavation portion was completed at the end of May 2015, where we then commenced on our mechanical electrical installation, which was completed with commissioning completed at the end of July 2015. Total duration for the project was about 6.5 months. We dealt with some very severe working conditions, primarily due to the water inflowing is about 170 degrees Fahrenheit, which drives our working temperatures over 100 degrees wet bulb. We had engineering controls with a ventilation system, which included a chillers, and we had a very stringent monitoring system to track our temperatures and control how long the guys were allowed to work in those conditions. In order to build this pump station, it required a bit of new technology. I mentioned our cooling system. So we basically have big refrigeration plants that make cold water that is pumped partway down the shaft where it goes through heat exchangers, and we blow air through that. Basically, when we're done, we're dealing with cold air in the mid 70 degree Fahrenheit. The other thing, at that depth, we have to make sure that we know we have good ground conditions and good ground support. So we have geotechnical monitoring consisting of extensometers and cable bolts with sensors to detect ground stresses. Another system we implemented from the very beginning was what we call our critical risk management system, which basically consists of identifying critical risks, which are activities that could result in fatalities. We then designed what we call critical controls to offset those risks, and the crews are trained on identifying and managing those risks throughout their shift. Although it was a short duration project, it was a very demanding project in terms of working conditions. I want to thank our contractor, Cementation USA, for completing that safely and producing a quality product when we were done. Along with that was the design and engineering work that was put into the project, also completed by our contractor. And I want to thank all the resolution personnel, outside support groups that helped complete this job.